9.1, adding and subtracting radicals, and then we'll do multiplying radicals here in just a minute. Okay. So in order to add and subtract radicals, they need to have the same radicand here, which is they need to say both be root 7. And then I can combine these two terms around the middle term. So that's essentially 5 root 7 minus 8 root 7 would be negative 3 root 7. The root 7 acts as almost like a common denominator there. You don't actually do anything with the adding and subtracting there. You just add or subtract what's out front. So 5 minus 8 is negative 3 root 7. And then, of course, I still have my second term plus root 11. And typically we write... Oh, sorry, yeah, root 11. So negative 3 root 7 plus 11. But typically we'd write this as root 11 minus 3 root 7. We'd put the positive component first, okay? But either way, same thing. Those are our answers, okay? Okay, how about this one? 10 root 5 plus root 20. Well, again, anytime we see a radical, we want to simplify it first. And I factor tree that and I say 4 and 5. Well, what's the square root of 4? 2. So 2 escapes the radical, and that's really 2 root 5. Well, 10 root 5 plus 2 root 5 would be 12 root 5. Notice I added or subtracted what was out front of the radical there, and I kept the radicand the same, root 5, almost like a common denominator. So 12 root 5 there. Okay, let's do another one. 6 times the cube root of x plus 2 times the cube root of x. Well, these both have the same radical structure. In other words, they have the same index here of 3, and they have the same radicand. And hence we can add those two. 6 plus 2 is 8, and keep that radical structure the same. 8 times the cube root of x. Okay. So anytime we have the same radical structure here, well, then we can add what's out front there, 6 plus 2, or subtract or perform that operation, okay? 8 times the cube root of x. And notice I keep that radical structure the same, almost like a common denominator, and then I'm left with 8 times the cube root of x. Okay.